The paper that we just published studied the really the only known protective mutation for Alzheimer's disease. This is the Icelandic mutation. This is the only mutation that has really strong functional evidence of protection in carriers who are fourfold less likely to get Alzheimer's disease than non-carriers. They're also protected against age-related cognitive decline. So we thought it was really important to study the oligomeric form of the protein, since we know that this is the most toxic form of the A-beta protein that builds up and sets Alzheimer's disease in motion and contributes most profoundly to its toxicity. And so what we did was compare the wild type A-beta protein to the mutation carrying protein side by side, using both biochemical assays to look at the oligomer assembly rate and functional assays on neurons to look at its binding and its impact on neuronal function. We thought, certainly what was known prior in the literature was that this mutation lowered A-beta production in general. But since oligomers are the most toxic form of the protein, if there were additional impacts of the mutation on oligomers, that might be additive to the initial effect of lowering monomer production. So we studied it side by side, and what we discovered was that the mutation actually negatively impacts oligomer formation. So it actually cuts the concentration of oligomers that are formed substantially. We also looked at the functional impacts. The mutation containing oligomers are a little bit more toxic than wild type oligomers. But we also looked at the binding, and there we found something quite unexpected, which is that the mutation containing oligomers actually bind 4 times lower to neurons than the wild type ones do. So 4-fold lower affinity binding to the synaptic receptors where oligomers cause the toxicity. So we really didn't expect this mathematically dominant impact on binding of this protective mutation. And so this is significant because it suggests that therapeutic approaches that are crafted to imitate this protective mutation, which in the past have been successful in other disease indications, would be wise to focus on reducing oligomer binding to synapses, since this is something that's very prominent, a very prominent feature of the protective mutation.